with a skier.
A skier starts from rest at the top of frictionless incline of height 20 meters as figured in 5.20. At the bottom of the incline, the skier encounters a horizontal surface where the coefficient of kinetic friction between skis and snow is 0.210. Find the skier's speed at the bottom. How far does the skier travel on the horizontal surface before coming to rest? Neglect air resistance.
Okay, right. Okay, now this question is like this. This skier slides down an inclined plane or a slope from A to B. Now, this is the first part of the journey. The first part of the journey is frictionless. So that means there's no friction between the surface of the snow and the skier. This is the first part. The second part of the journey is after accumulating, coming down from the slope, it accumulates a certain velocity. So you find out what is this velocity, right? Then with this amount of kinetic energy, it goes through a distance of d. But this time, at the horizontal level, the snow has friction and the coefficient of friction is 0.210. So there are two parts. One part friction, one part the slope, no friction. Another part the horizontal distance, there is friction. Okay. So we are going to calculate the first part first. How much is the velocity? How much speed it has accumulated at the bottom of the slope? We're going to use the conservation of energy equation. Initial kinetic energy 0 because they say starts from rest at the top. So initial is 0. And also the initial potential energy is is mgy. Mgy is 20. The vertical height is 20. Finally, at the bottom of the slope here, the velocity is a certain v. The v we don't know. And at the bottom of the slope, the potential energy is 0. Okay. So this one no more becomes 0. This one also no more becomes 0. So we are left with 20 mg is half mv square. 20 mg half mv square. Even then the m can cancel away. M can cancel away. So we have v square, half v square equals to 20g. Half v square, 20g. So the 2 move over to the other side. V square is 40g. And v is square root of 40g. 19.8 meter per second. So we use the conservation of energy. Any questions so far? The first part of the journey?
No questions, sir.
No. No, then we look at the second part. The second part say after traveling to the bottom, then it will move a horizontal distance. So the horizontal distance, we are going to use the work energy theorem. Work energy theorem means the energy is converted to work done. Okay, the energy is converted to work done. So how much is the energy converted to work done? The loss in kinetic energy is actually the work done. So we're going to calculate how much energy is due. Before that, you have to calculate how much is the frictional force here at the bottom of the slope. So the frictional force is F equals to mu n, where mu is the coefficient of friction. So at the horizontal surface, the normal reaction is mg. Okay, this is true provided it is on the horizontal surface. When it is horizontal, the normal reaction is mg. Okay, so we are going to use this equation. This equation. So the loss in kinetic energy, final kinetic energy 0, initial kinetic energy half mv squared. This is equals to the work done on friction, F times the distance. F is how much? F is pointing against the motion, so it's negative 0.21 mg, 0.21 mg. The distance traveled, we don't know. Distance traveled, we call it d. So the m and m can cancel off. M and m cancel off. The g negative 0.21 is 0.21 GD. This one 19.8 square. 19.8 square is 40 G. That's how I get the 40 G here. So divided by 0.21 G, you have the distance traveled 95.2 meters. Any questions so far?
No questions, sir.
No. So the first part, we use the conservation of energy. The second part, we use the work energy theorem. Work is converted, energy is converted into work done. Right? So both. Question 5.8. Give two reasons why the skier typically assume a crouching position down when going down a slope. So why should this skier crouch like that? When he bend down the body and pull himself together, his surface area becomes smaller. If you open up like that with the chest, and you are actually blocking the air. So when you pull yourself together, you are actually reducing the surface of the body that is exposed to air. So what happened? What happened is that if you stretch out, there will be more air resistance. If you pull yourself together and you bend down like that, smaller surface, there will be less air resistance. So the answer is to reduce the air resistance due to air brushing against the surface of the skier's body. Now, normally in a competition, they want to see who can travel the furthest. So in order to travel the furthest, you must not waste your energy on friction, right? You try to reduce the friction so that most of your potential energy and kinetic energy will be conserved and enable you to travel a further distance. So you reduce the surface, the resistance, the air resistance. So after that, the work done on the air resistance will reduce the kinetic energy, right? So if the work done, the air resistance reduce the kinetic energy, then finally you have less kinetic energy at the bottom of the slope, and you can only travel a shorter distance before coming to rest. However, if you pull yourself together, less energy will be wasted on the friction or air resistance. Your final kinetic energy at the bottom of the slope will be higher, so you are able to move a further distance. Any question?